Dogs are a critical component in many individuals' daily lives. They provide companionship, emotional support, and entertainment for the people who care for them. Yet a considerable amount of people cannot dedicate enough of their day towards exercising their dogs, despite it being critical for the health and well-being of the animal. The preferred method of exercising for trainers is walking, running, or swimming with their dogs, and a popular combination of the three is playing fetch. Fetch is quick and effective at what it does, but that still doesn't always work for people with sporadic schedules. Short of paying for a caretaker to watch the animal in the absence of the owner, the only other option is to buy something that effectively does what the owner would otherwise do. Enter the Autopupper. The Autopupper fills this gap so that a conflicting or ever-changing work schedule will not interfere with the necessary outdoor activity that every dog wants and needs. The Autopupper is an automatically operated device that launches gravity-fed tennis balls at predetermined distance. The balls are to be dropped into a feeder whenever the pet wants to go for another round of fetch. This allows for the pet to play and exercise whenever it feels inclined. By allowing dog owners to remotely exercise their pets and at the discretion of the animal, we alleviate the stress and the time constraints that would otherwise be present while simultaneously allowing the animals a nearly unlimited amount of exercise time. This increases the well-being of both the animal and the owner. The true competitors we saw on the market range from small, compact, and low-power launchers such as the iFetch to variable range outdoor launchers like the GoDog Go G3 fetch machine. The iFetch launcher is primarily made for indoor use and uses specialized balls to achieve its desired function. The primary advantages are the sleek design and portability, while the primary disadvantages of this are the required use of their proprietary ball and its focus on small-sized dogs only. The GoDog Go launcher is much more robust, using variable ball sizes, adjustable launch distances, automation, different power options, and more for a more premium price. The primary disadvantages of this design are the high cost and the awkward shape, which can prove troublesome to transport and storage. The primary advantages are its adaptability and user-friendliness. In order to differentiate ourselves from the competition and keep the Autopupper within reasonable guidelines, we needed it to do multiple things. Be easily loadable by a dog medium size, have an adjustable launch distance, weigh under 20 pounds to be easily moved, fit within a cubic foot and a half for easy storage and portability, and cost under $150. Originally, we wanted to keep the machine small and compact while generating as much torque on the ball as we could from our motor. This led us to our first design option of using helical gears. This turned out to be way too expensive, and even spur gears quickly put us over our budget limit. We then turned to 3D printing, but we were worried that any plastic would wear quickly and deform from the heat due to friction. We then moved on to a more versatile option using a belt and sheath mechanism. Our first design involved crossing the belt, but we found no way to stop the dog from walking or generate the torque we thought we needed. From there we moved to a more complicated system using 4 pulleys and a 2-sided V-belt, but our initial calculations made it seem like we would encounter slippage. Once the belt and sheath was considered not feasible, a chain and sprocket mechanism was considered. Because the launch wheels needed to operate in opposite directions to create topspin, this mechanism is ideal because an idler can be used to act as a driver, since the chain and sprocket can transfer torque more effectively than a belt and sheath. This mechanism allows for more versatility in the design, since the ideal contact angle for no power loss is 120 degrees compared to 180 degrees for belt and sheath. In regards to cost, the chain and sprocket mechanism is cheaper than both the belt and gear mechanisms. The leading factors that the mechanism selection was based off of are cost, ease of manufacturability, compactness, easily replaceable hardware, quiet operation, and safety. After completing a decision matrix, the chain and sprocket mechanism was found to be the best option to use. Even if the chain and sprocket wasn't found to be the best option, the prototype will still have to be built using this mechanism because it is much more feasible to construct due to time and money constraints on the team. Our long-term commercialization plan has multiple parts and obstacles to it. Ideally, we want to reduce our production costs, establish a physical location for manufacturing, and build a brand to help expand our reach in the market. However, all these things have their respective obstacles. To sell the product at a competitive price, we need to more optimally source our raw materials and reduce assembly time. In order to set ourselves up for successful production and scale in this market, we need to raise upfront capital in a competitor-heavy domain for things like manufacturing equipment, rapid prototyping solutions, distribution channels, and more. Attracting new investors in this saturated market would be difficult. In order to build a brand around the Autopupper, we would give it a more streamlined look, but that would entail an extensive ergonomic redesign of the shell, delaying how quickly we can enter the market. Ultimately, we plan to sell the Autopupper for $200. Now, why would you want to spend that much on an automated fetching device? Because $200 lets you rest assured that when you're away, your dog is happy and healthy doing the thing that he or she loves. And is there anything you wouldn't do for your dog?
I'd say, but like, oh god.